back to AWS On Air. I'm Jasmine Kiles, one of your hosts that's been here on the journey with you throughout the day, and I am joined by my lovely co-host.
Thanks for having me.
How are you?
It's good to be here. My
Who
first
are you?
Who am I?
Who are you? It's your first AWS On Air
First
segment.
AWS Summit as an on-air host.
Yeah.
Folks tuning in, my name is Robbie Belson. I'm a developer advocate. I cover Edge portfolio. I'm happy to be here.
Yeah, good. Are you pumped for your first segment on the summit?
Started off nice and early, 9:15 a.m., had a session talking generative AI.
Yeah.
Now we get to continue that theme of machine learning and builder tools and optimization and continue the journey going.
I'm most excited for this topic that we have going here, coming up here. So tell us who we have joining us here on the stage.
Absolutely. I'll let the guests introduce themselves.
Sure. Hi, everyone. My name is Rishabh. I'm a senior product manager with Amazon SageMaker. Really excited to be here and talk to you about inference optimization capabilities, which we recently launched.
Hi, my name is Dmitry Soldatkin. I am a senior ML specialist solution architect. I work on the SageMaker Inference. Really happy to be here. Thank you for having us.
So maybe just a level set to kick things off, starting with you, Rishabh. As you think about the landscape here, training, fine-tuning, deploying models, we're going to talk today about model optimization. And it's no secret that it's complex, it can be expensive. Were those sort of the problem statements that you were seeing that motivated the release of this feature?
Sure. So I can give you some context, right, why we invested in building this particular feature. So if you look at customer use cases, it varies from use cases and requirements. It varies from a particular application to another application. For example, a chatbot, customers want to prioritize and focus on latency because it's super critical to offer a great interactive experience to end users. Similarly, for real-time applications, which are very high traffic, like a fraud detection use case, right? In that case, you have millions of transactions per day, and you want to optimize for throughput. So the target metric, and it varies from use case to use case, right? And what customers today try to do, specifically with generative AI models, is to optimize them in order to achieve those particular metric, right? And they want to optimize for either cost or optimize for performance. Now, there are open source libraries which allow them to do that, like VLLM, wherein they can particularly optimize with techniques such as speculative decoding or quantization or compilation, and through that they can improve the price and the performance for their workload. But the entire process is very tedious and it time-taking because they have to go through a lot of open source documentation, figure out what is the right library to use, then they have to figure out which is the right container to use, model server to use. Right. They have to iteratively benchmark and prototype, and then understand if the final performance and cost metrics matches their expectations. And once they are sure, then they go into production. But this entire process would take about a month to 2 months, right? So with this new feature that we launched with SageMaker, we are essentially offering an end-to-end toolkit wherein customers can come and say that, okay, for this particular model, I want to optimize it with speculative decoding, and they can run an optimization job ahead of time. Then they can trigger a benchmarking job and look at the performance metrics. And once they are confident that this is the right model and optimized model, they can then deploy in one click. So we're making this entire process much more simpler, so customers can optimize and deploy models on Amazon SageMaker within a day, right? Yeah. Which would earlier take a month, right? So that significantly improves their time to market for generative AI applications. And it also helps them reduce their cost and burden for their DevOps teams.
Yeah, I like how you're calling out, the amount of time reduction, right, as well as the amount of cost, right? By saving that time, you're also inherently also saving cost. So tell me a little bit about, you keep mentioning the customer. What types of customers did you build this for?
So we are specifically focusing on customers who are evaluating open source generative AI models like Llama, Mistral, or Mixtral. So a lot of customers are using these open source models, fine-tuning it, then deploying it on SageMaker today in order to, across a spectrum of applications, as I said, right? It could be fraud detection, it could be product recommendation, or chatbots.
Okay, awesome. So, you have a demo?
Yes, we do have a demo.
Let's see the demo, and then we'll see if we have some questions coming in here on Twitch for us.
Absolutely. So let's see the demo. As Rishabh mentioned, we have two ways to employ this new inference optimization toolkit. We can do it from the SageMaker Python SDK, or we can do it from the Jumpstart UI. We will start with SageMaker Python SDK. And in this demo, I'm going to walk you through deploying a Meta Llama 3 7TB model, which is a big model, from Jumpstart using different optimization techniques. So let's get started. The first use case is deploying the model using speculative decoding, and we will be using SageMaker provided draft model. Just a really quick, the speculative decoding is a technique to employ a second model. We call it a draft model, which is smaller and it works faster. So basically, the draft model generates the output, and big model just validate the output. So that's in a nutshell how you achieve basically speed up in inference. We will be using our model builder class. It's a really easy way to deploy SageMaker models. Really easy, just using model builder. You create a model builder objects, and model builder objects has some additional techniques. For example, you can display predefined benchmark matrix, and yeah, that's how you do that. And you can see that we already tested this model on a different instance types and with different configuration, with and without speculative decoding.
So this gives you a benchmark from which to measure how much incremental performance am I getting from this inference optimization toolkit.
Yeah, exactly. And it gives you an idea of what to use. For example, you know that you will have, for example, 32 concurrent users, and you want to achieve some, I don't know, token latency like 20 milliseconds, for example, and that gives you a better idea what to use.
So just to add there, so this pre-benchmark data is only for the top popular models. Because for like a custom model, we won't know what the model is, so we can't provide that. So, but we are offering a benchmarking toolkit as well, where customers can trigger a benchmarking job and get the similar metrics.
Yeah. So in this particular example, we will be using our LMI optimized configuration with a P4D instance type. So you can just run this get deployment config method to basically validate that everything looks correct. And there is, you probably notice some red color on the screen. It doesn't mean there is like errors or something is wrong. It's just some debug information, which, well, in the preparation to the session, we basically put
warning.
Warning, yeah. It's a new feature. And then you just basically, after the model builder class is ready, you just build the model, just one line of code, and another line of code, you just deploy it. In the interest of time, I pre-deployed the model because a model deployment takes about 5 to 6 minutes. But I can show you that model is deployed and it returns the output. Yeah, here's the output from our model. Meta Llama 3 7TB deployed on P4D using SageMaker draft model.
So you've abstracted away that specialized domain knowledge for speculative decoding into a single line of code?
Yep, pretty much.
I like it.
Well, 2 lines, of course.
2 lines of code. Sorry.
2 lines.
Should have said warning. This is awesome.
OK. Second use case is to deploy the same model, but now we will be using the open source draft model.
Okay.
Well, some customers want to use their own draft models, and this use case is we will show how to do that. Same steps. We create a model builder class, and then we just run our optimization job. And in this optimization job, the model source, as you can see, is the Hugging Face Tiny Llama model.
Okay.
So we'll basically just using this model as our draft model.
Got it.
So, well, you have to supply your own token. I'm not going to show you my token. And same step. two lines: deploy, optimize, and deploy. And then you just basically run the prediction, and that's it. Really simple.
Okay. Wow. That was very simple. It's probably the.
Okay, let me slightly complicate it.
Okay. Okay. Good. I'm ready for it.
Yeah. Well, right now we just showed you how to deploy the model. But
Right.
what if you want to run some optimizations, right,
Yes.
before your deployment? We support two types of optimization. The first is quantization. And quantization, again, really quick, it's a technique to reduce the model size. Instead of using the full precision floating point numbers, we reduce them to half precision or even less than that.
Okay.
In this particular case, we will be using a technique which is called AWQ, activation weight quantization, and we will be reducing the numbers to 4 bits integer.
Okay.
So, well, you know what to do. You create a model builder class, and then you run optimizer job. And this is the configuration that we want to employ AWQ quantization. At this time, we support AWQ quantization only, but it will be fast follow-up. We will obviously add another quantization methods going forward. You can also need to specify S3 location where the quantized model will be saved. So you just run it basically once, and then you can reuse this model going forward.
Okay.
This quantization job, this is a big model. So it can run for, well, close to an hour. So again, I pre-run it. When the job is running, you can monitor the progress of the job. If you go to the SageMaker Studio,
Okay.
Inference optimization, and you can see all this quantization job. It was completed today, and if you click on it, it will show you some details about the job.
Oh. What kind of details am I going to see here in this job?
You can see the model source, what was the source of the model, log file, which is available if you want to check what's going on, and also the path where model was saved, and the technique which we used, and some SageMaker environment variables, which, again, useful for debugging.
Yeah.
I think
Okay.
what's become clear to me is that the deep extensibility from day one. You're integrating with Hugging Face models, then you're integrating with model builder classes, and then you're already integrated in the SageMaker Studio. So we're reusing developer workflows that are already well known and understood, and making specific parts of the developer journey easier. That must have been the intent.
Yeah, so I think that's the biggest problem that we heard from customers. Like, we know the model, we know the instance, but how do we make sure that the model runs well on that instance? How do I optimize it with the latest and greatest techniques in a simple way, right? Like, what we have done now is, like, you can quantize this model with 3 simple steps, right? Otherwise, earlier means you had to procure the hardware, understand which library to use, then figure everything out, right? So I think that's the biggest advantage with this particular feature.
Okay. And so after the quantization job is done, you can, again, just deploy it. And in this particular example, we will using a much smaller instance. Before that, we were using P4D, which is the, well, last to second generation of NVIDIA chips. And this is even a previous generation. Much cheaper instance, about like 6 times cheaper than the previous one. And because model is quantized, and then model is deployed. Again, it takes 5 to 6 minutes to deploy, and I can run prediction.
So you're able to quantify the savings easily in terms of my instance type hourly cost.
Yeah, absolutely. Very simple math. And this is the output. And finally, the last optimization which is available is to compilation of the model. As you probably know, we have our own, custom silicon neurons, and you can deploy a model. But when you're deploying the model on our custom silicon, model needs to be compiled. It can be done at the time of the deployment, but it takes time. So we basically created a mechanism to do it beforehand. And again, same step, I just want to, I know I'm probably sound like a broken record, but I really want to get this message across.
Builder class.
Model builder class, really simple.
Yeah.
And create a model builder class and slightly different parameters. So you have some parameters. There is we can provide a link to the documentation where these parameters are described. And again, deploy the model and run prediction. One thing to notice, don't forget to delete all your endpoints. You are not charged for the resources you are not
If
using.
you weren't going to say it, I was going to say it.
But this was Python SDK. So let me quickly show you how to do it in a UI.
Okay.
So I'm switching to SageMaker Studio, and I'm going to open the jumpstart. In a jumpstart, well, we have a list of different providers. We are going to stick with Meta in this example, same model, Llama 370B. And there is a new button, Optimize.
Aha.
If you click on Optimize, and well, you have to accept end user agreement, and then you have new options. You have a quantization option. If you click on it, it will provide, well, in the future it will be drop down different quantization techniques, or you can provide the speculative decoding.
Oh.
And again, you have a choice, SageMaker draft model or use your own model. If you click SageMaker draft model, then you need to provide a path, and you can just click create a job.
So whether or not you're launching that downstream instance, you're getting the model artifacts that are optimized regardless.
Yep.
So you could bifurcate those two processes in the event you want to run it on a more constrained instance type in an edge computing environment, my world, for an example.
Exactly.
For example, yeah. And so the job is done because it was a really simple job just to apply speculative decoding. But I want to mention one more thing. Right here, we have evaluate performance. If you click on it, you have an option to create evaluation job, which will basically tells you how well your model is performing.
Okay.
So it's again, it's a new feature which we introduced, and it's basically a model evaluation feature. And evaluation output will be saved into some default bucket, and you can just evaluate it. Again, take some time to do it, so I'm not going to do it live, but yeah.
So what are the typical performance gains that can be expected when you are using speculative decoding?
That's a great question. So what we have seen based on our internal benchmarks is that for some of these popular models like Llama, Mistral, we are seeing up to 2x improvement in throughput and up to 50% reduction in cost per million tokens, which is significant.
Yeah.
And this is the important key call out is that this is without any accuracy impact. Right, so you get the same accuracy, the same quality of your output without any impact. So that's the best part of speculative decoding. Quantization, again, you can deploy on a smaller instance, so you can save costs, but there is going to be some accuracy impact because you're using a lower data precision type, and that's why you can probably do some level of benchmarking to evaluate the performance. And compilation is something that you need today, but I think what we have done here and which really benefits customers is that we have put in infrastructure improvement through which customers can compile the model, generate the compiled artifacts, and then load it and cache it during deployment. Right.
Yeah.
So that way it improves the overall experience and performance for the deployments.
Yeah. Oh, all right. So where can I go to learn more?
Yeah.
So we have a What's New page for this particular launch, and we have a couple of blogs as well, which we can share.
Yeah. And I think we're dropping some links here in the chat, but one of those is on the AWS machine learning blog, which I love reading.
Yes.
Getting to see all of this stuff and see some of the demo information in there as well.
Yeah, we have two-part blog series. So in the first blog, we get into the high-level details, and then the second part, you can get into the details of like how to apply it through PySDK or through the UI.
Yeah, well, I look forward to seeing it, and hopefully, like I said, we're dropping those links into the chat, so you'll get some new viewership on that blog.
Awesome.
All right, great demo. It was wonderful to talk with you all and learn about this new feature that you can use with SageMaker Jumpstart. So congrats on the launch, and we look forward to seeing you back on AWS On Air soon.
Awesome.
Yeah.
Thank you so much for hosting.
Thank you very much.
Of
Yeah,
course.
thank you.
Yep.
All right, and we will be back with more, so stay tuned.